All right, here is where algebra tiles are really going to start to come in handy when we want to solve equations. So we are going to solve some equations using algebra tiles. First, remember we have to build them. So we have x plus 3, or 3 plus x on this side. Now on the other side, we have to put 5. So 1, 2, 3. The line represents an equal sign, 4, and 5. So this is equals. So if we have the exact same thing on two sides, exactly the same color, same size, we can take them off. So I can take off one from here, 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 one from here. And I am left with an equation or a solution over on this side. I got down to just plain old x, and it equals 1, 2, so x equals 2. So the answer to this is x equals 2. Now realistically, what we did is we took 3 away from both sides, which left us with x equals 2. For the next problem, we start with, we're going to call it x even though it says z. It doesn't really matter, it's just the variable. So I have x plus 2 equals negative 6 this time, so we need to pull over negative 6. 1, 2, 3, 4, 5, and 6. So x plus 2 equals negative 6. We have our equation built. I don't have exactly the same things on both sides, but I want to get x by itself. Sorry, I'm going to just move these out. So I need to get rid of these. How do we get rid of something? We zero it out. So to zero out those, I'm going to add 2 red ones. That would zero out and that would zero out. But remember, we have to keep it balanced. So if I add 2 red to the left side, I also have to add 2 reds to the right side. So now I haven't really changed the value of my equation because I did the exact same thing on both sides. So now these are zeroed out, so they disappear. And whoops, sorry, that one decided not to leave. And we're just left with x equals negative 1, 2, 3, 4, 5, 6, 7, 8, negative 8. Now just to replay what we did, and this is a z of course, we had to get rid of this 2. We subtracted 2 from both sides, or added a negative 2, and we ended up with z equals negative 6 and another negative 2, which is negative 8. And lastly, but not least, let me delete these. We have x plus 1 on the one side of the equal sign and 4 on the other side. Again, we need to get that x by itself. To do that, we need to get rid of the 1. To get rid of the 1, we have to zero it out. So I'm going to add a negative 1 there and a negative 1 there. I'm going to do this one as we go. So we add a negative 1 to this side and a negative 1 to that side. And that gets rid of these 2. And that will actually get rid of these 2 also, because they're a 0 pair, so we can get rid of them. And we're left with x equals 3. And if we did it here, it would be x equals 3 here also. So that is one-step subtraction thing. So using models to solve equations, how do we solve an equation? We have to get the variable on one side of the equation, like x equals 4, by using inverse operations. So operations that reverse or undo each other. So when I think of inverse operations, I think of 2 main ones. We have addition and the opposite of addition is subtraction. And then multiplication and division. Those are the inverse operations. So we just undid, back here, we undid addition, plus with subtraction. Let's look at the next bit of problems. These first two are exactly what we just did. Actually, all three of these are exactly as we just did. So you give these a try. Oh, hey, there's some more for you to try. So let's go back and we'll do number 3 because that's a little bit different. So let's build number 3. We have x and then we have minus 3. Minus and negative are the same. So x minus, oh, sorry, I'm building them on the wrong side. X minus 3 equals negative 4. Okay, do I have to make 0 pairs? We have to get x by itself. I don't think I need 0 pairs to do that though, because I have exactly the same size and shape and color on both sides of the equal sign. So if I take 1 from here, I take 1 from there. Take 1, take 1, take 1, take 1, and we're left with x equals negative 1. So here what we did is, if we were going to solve it using just numbers, we would do the inverse operations. So we would add 3, and we would get x equals negative 1. Let's just go back and think, could we have done this another way? We could have. That would have shown you the add 3. So here is where we started. Here is what we're saying. It does the same thing, but really we could consider this as adding 3 to both sides. If I added 3 to both sides, it just makes it a little bit longer, but again, we 0 paired all of these. So these are all 0 pairs, so they disappear. I 0 paired, whoops, I don't move that. These, so those all disappear. Those all disappear. And we're just left with x equals negative 1. So that is really adding 3 to both sides. And now we have x equals negative 1. So I'm going to let you do those 2 and those 3 on your own. And then now we're talking about modeling ones where we have 2x equals 6. So building 2x, there's 1x, I need 2 of them. 2x equals 6. I'm going to randomly place these 6 to begin with. 3, 4, 5, and 6. So 2x equals 6. I just want to know what 1x equals. So to do that, have you ever split candy or something with somebody? You say, you take 1, and I take 1. You take 1, and I take 1. You take 1, and I take 1. And then the answer is I get 3, or x equals 3. So what we did is we divided our candy up between 2 people. And 2 divided by 2 is just 1, so we get x equals 6 divided by 2, which is 3. That's how we do it mathematically, and this is how we do it using a model. Next one, 4x. 1, 2, 3, 4x equals 4. 1, 2, 3, 4. Again, now we have 4 people we're dividing the candy up with. You get 1, you get 1, you get 1, you get 1. And the question is, what is 1x equal? Well, that's just this part. Here's 1x, and it equals 1. Mathematically, again, we want to undo multiplication, so it's 4 times x. To undo multiplication, we do division. So we divide both sides by 4. 4 over 4 reduces to the number 1, and we get x equals 4 over 4 reduces to the number 1, 1. So there it is, modeled and mathematically. Next one. I'm going through these fast, but feel free to pause or rewind. Here we only have 3 x's, and we have 3x equals 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, we have to split up our candies between 3 people. 1, 2, oh, excuse me, 1, 1, 1, 2, 2, 2, 3, 3, 3. Hey, look, each x gets 3 candies. So each x is equal to 3. And I should not put that there because then you can't see mathematically. Again, we took our 9 candies and we divided it by our 3 people. So we get x equals, because 3 over 3 reduces to be the number 1. And this is 9 divided by 3, which is 3. So there we go, is multiplication. Pretty straightforward. I'm going to have you do this set. Oh, I didn't even give you, oh, I think I did. It says here, look, complete 13 through 15 on your own. Then we're going to move on, come back when you're done, and we'll move on to division. This is trickier. It's really hard to show this with algebra tiles, but we will give it a try. Half of an x. I'm going to take an x, I'm going to turn it on its side. If I think about just half of this x is 4. So if this half of the x is 4, 1, 2, 3, 4. If that half is 4, the other half has to also be 4. 1, 2, 3, 4. So if half the x is 4, the other half is also 4 because they're even halves. So now we are left with actually not half of an x equals 4, but 1x equals 8. How do we do that algebraically? Well, it says 1/2 times x, or x divided by 2 is another way to write it. So to undo that, I'm going to multiply this by 2. And if I do it on one side, I have to do it on the other. So I'm going to multiply this by 2. These two cancel each other out, and we get x equals 4 times 2, which is 8. Next one. Let's see. Yeah, sure. Delete. Again, we have x, a third of an x this time. So a third of an x equals 3. This is 1x equals 3, right? I only want 1/3 of the x equals 3. So let's see. If I cut this x into 3 pieces, this piece would be a third of the x. This piece would be a third of the x, and this piece would be a third of the x. So if a third of the x equals 3, then this third of the x would also equal 3. And this third of the x would also equal 3. So altogether, I don't want to know 1/3 of an x. I want to know the whole x. So the whole x, 1x, is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have x equals 9. Again, if this is a third of the x, to undo x divided by 3, I'm going to multiply this by 3. Multiply this side by 3. Those cancel out. So we get x equals 9. Now this last one is the trickiest to show. So it says half of an x, which we've done before. There's an x. And last time we did this, half of the x equals 3. Actually, this isn't. So half the x equals 3, 1, 2, 3. I don't know why I was thinking this was harder. I need 2 halves, so that half equals 3. The bottom half also, since it's the same as a half, it has to equal 3. So I don't want to know what half an x equals. I want to know what 1, oh, there's my eraser being crazy. 1x equals, so here we have it, 1x equals 6. So if half of an x is 3, then 1 is 6. And how do we do that mathematically? Multiply by 2 to cancel that out. Then we'd multiply this side by 2 to keep our equation balanced, and we'd have x equals 3 times 2, which is 6. And that is it for today.